But let's get started on our compound angles. So just as a reminder, these are your compound angle formulae that you need to know. I can't remember if I dotted them up throughout the lesson. I'm not sure if I have. But if I haven't, you've got screenshots from the last lesson. I've also put I need to see the Google form, the formula sheet onto Google Classroom for you guys. So if you haven't got a copy of it, at the bare minimum, I would even just take a screenshot of it and like add it to an album, like a favorites album or something on your phone. You then have it to refer back to any time that you need. Just remember, all of this is on the formula sheet. So none of these formulas you actually need to learn off by heart. They're all there for you. You just need to be able to apply them. All right, so these are our compound angle formula. We're now going to practice actually putting it into use. So this first example that I have here is actually sort of what we were doing already on Wednesday. Told you guys that my laptop's having a time with me, and I don't know why. I don't know what I've done to deserve that, but anyways. All right, so we're gonna have a look at this first example here, which is just dealing with the application of our compound angle formula and then reductions in it. We did a few of these examples towards the end of our lesson on Wednesday, but obviously we're just going to start off with this and then we're going to build up in terms of the questions that you can expect. Okay, so this question is asking us to determine the value of, usually it would say without the use of a calculator, which I should have said here, I just didn't. So you can imagine it saying without the use of a calculator. And guys, remember we spoke about the fact that the second you see without the use of a calculator, it means somewhere in your mind you need to be thinking of your special angles. Now, I drew the special angle triangles for you the other day. Again, just use your calculator. As long as you show all your working out, I'm not going to know if you use a calculator, whatever. When I say show your working out, show the substitution, show the additional fractions or the multiplication of fractions. That's all you really need to do, but use your calculator to double check. If you can't remember what cos of 60 is, just type it in your calculator so that you do get it right. Okay, so remember I said to you guys, keep your acute angles. If you then need to apply your co-ratios, you can apply your co-ratios later on, but keep the acute angles to start off with. Apply the reduction to all the angles that are not acute, and like I say, you can adjust things later on. Now, what you'll find, especially when you try the next one by yourselves, is there's often different ways to do this. All right, now you might apply a co-ratio to a different trig ratio. You might have seen a different compound angle formula that you have now gone and manipulated. There are a couple different methods to solving these types of questions. All of them will be correct. So we will never mark you wrong if you've done it differently to the way I have done it or your teacher's done it. Obviously, as long as you apply your formulae correctly and you apply your reduction formula correctly, it's fine. So as I go through it, if you had thought of something else to do, and when you try the next question by yourselves, if you do it slightly differently, it's fine. As long as your final answer is good. Obviously, you can ask me as we go along if you want to double check, but just bear in mind, especially when it comes to trig and simplifying things, often there's a few different ways to do it. I've said this as well before when we did trig identities. All right, so I'm keeping my acute angles. That means cos 65 for now is going to stay cos 65. The cos of 295 can be written as a reduction of cos 360 minus 65. Right, then I've got minus sine 115. Again, it's obtuse angle, so I'm going to apply my reduction. 180 minus 65. And cos of 205, again, reflex angle now, I'm going to apply a reduction. So cos of 180 plus 25 degrees. All right, so hopefully what you're starting to see, because remember, guys, in order for me to apply my compound angle formula, the angle A's must match up and the angle B's must match up. So right now as my angle A, I've got 65 at both of the first terms of each, or the first factor of each term. But the problem is I've got 65 and 25 as my angle B's. They aren't the same. We're going to have to make them the same. But let's sort out our reduction before we stress about that. Okay, so applying my reduction, cos 65 times, now 360 minus, cos is positive in quadrant 4, so cos of 65 degrees. minus sine 180 minus sine is positive in the second quadrant, so we've just got sine of 65 times cos of 180 plus 180 plus is quadrant 3, so cos is negative, so negative cos 25 degrees. So at least now I've got all acute angles. From there I can start changing things. So guys, right now, if you go back up to your reduction formulae that we know, right now we've got a situation where my first term is cos 65 times cos 65. My second term is sine 65 cos 65. So what I need to be doing is I need to be thinking about which formula might apply here. So it's cos minus sine cos. We know that none of them form that. It either has to be a cos plus or minus sine, or it is sine cos plus or minus cos sine. So either I'm going to be working with, and obviously now we haven't got that in our screen, either I'm working with this situation where it's a cos minus sine. So that would mean that I would have to change this negative cos 25 to a sine, or we have a situation whereby we could change one of these causes over here and we could have a cos sine cos. And remember, they factor, so you can change them as you please. So you could have the sine cos minus cos sine. So one of those reduction formula will apply. It would depend on the co-ratio you now choose to use. It's completely up to you. It makes absolutely no difference. Personally, I saw the cos sine ratio first, so that is the one I personally would go with. But again, like I was saying earlier, there's lots of different ways to do this, whatever you see. Okay, so in terms of what I've just shown you here, my goal is that I'm going to keep this cos, but I want this now to be minus sine. That's according to one of my compound angle formulae. Right, so negative cos 25, I can write, and obviously I want to now change it to a sine, so I'm going to have to write it as a 90 plus or minus. So if I just keep everything the same, obviously because I'm happy with everything as it is, but now I apply a co-ratio to this last factor, I would have times negative cos of 90 minus 65. 90 minus 65 will get me the 25 degrees that I want. And remember, because it's cos 90, the the name changes to sine. Now, the next thing, guys, is because you've got a negative times a negative, the sign becomes plus sine 65, and because of that co-ratio times sine 65. So now I've got a compound angle formula that I can work with. Compound angle formula, again, just in case you didn't hear me earlier, is now a situation of cos A times cos B plus sine A times sine B, and that equals cos of A minus, oh, don't know what that was, A minus B. All right, so that is the compound angle formula that I'm working with. Because I've now got it in the format I want, I can go straight to applying the compound angle. So I've got cos of angle A, which is 65, minus angle B, which is also 65. And so I actually have cos of 0. Now, I've said this to you before, this is actually a special angle. If you learn it, great. If you use your calculator, great. The way I learn these ones, the way I remember these ones is with my graph. So that's a cos graph, not the most beautiful cos graph I've ever drawn, but it's a cos graph. 0 degrees is over here, and that means that my y value, so my ratio, is at 1. So cos of 0 degrees is actually just 1. If you didn't know that, you put it into your calculator and you get the answer. So remember, guys, with these questions, you want to keep your acute angles, apply your reduction formula. If you then need to, in order to manipulate the expression that you have to match up with one of your compound angle formula, you can then use co-ratios, but otherwise you work starting with leaving your acute angles, moving on to reduction formula, doing co-ratios if and only if you need to. All right, so there's a question here that I'd like you to try. I'm just going to make this a bit smaller. Apparently, I'm going to make it a bit bigger. Right, so this is the question down here that I would like you to try for me. If you have questions while you're doing it, please obviously ask. But cos 59 times cos 346 plus sine 121 times cos 76. I want you to determine the value of that expression without the use of a calculator. I'm going to leave my answer up there, A, if you want to screenshot it, and B, if you just want to refer back to what I did in the previous example to sort of guide you. And I think the other thing that I should probably do that would be quite helpful would be to put our compound angle formula here for you. It's going to be ridiculously big. I'm sorry, I'm going to move back to it now. Give me 2 seconds. Got quota box somewhere. Right, there we go. There your compound angle formula, just in case you need them to refer back to. Let's try this example. I'm going to give you 5 minutes and then we'll have a look. Okay, so remember, leave your acute angles to start off with. Start by applying your reduction formulae, and then you can go back and apply co-ratios if you need to manipulate it to match up with one of your compound angle formulae. And remember, Charles, if you have questions, just ask. You can put in the chat or you can unmute yourself, but please do ask if you've got questions. Hey guys, can you just give me a thumbs up when you are done? You can give a reaction or you can put in the chat. No, thank you. Abyssal, thank you. Sivona, thank you. Mashika, thank you. Okay, well, it looks like we're all sort of getting to be done. Morgan, thank you. Oh. All right, guys, I'm going to put up the answer. Firstly, remember to take screenshots. Secondly, remember that I said that you might have done it a bit differently. So when it comes to the co-ratios and stuff, you could have chosen to manipulate one of the factors that I potentially haven't manipulated. What you're looking for is that the answer is the same. If you're not 100% sure, just ask, but it could look a little different. Check first that your final answer is the same, and then you can go back and check the working out. All right, I'm hoping we've all screenshotted this first example here. I'm about to move away from it. So if we have a look at this, we can now go and double check. So the answer you should have gotten is √2/2. If you wrote your special angle for cos 45 as 1, as 1/√2, that's also fine. Technically, we always leave our answers with rational denominators, but because it's a special angle and you're doing it without a calculator, some teachers do teach it to you that cos 45 is 1/√2. So both of them are fine. Now I definitely can. Whoopsie daisies. Alrighty, so your marker allocation here would be for your reductions. Okay, apparently the pen isn't going to work here. So the reductions of your cos and sine. For your co-ratio, there was no sign change for this one. So getting your correct angle, if we're feeling generous, for your answer, if we're feeling generous for getting that, your angle that you're working with is cos 45. So these questions are generally 4 to 5 mark questions. Obviously, depending on how much manipulation you have to do. Generally with trig, and I said this to you when we did the grade 11 revision. Generally with trig, every reduction that you do, every co-ratio that you apply, that's a mark. So that's why I've given marks for those specific things, the reductions and the co-ratio. It also depends on the test. So let's say, for example, you've asked 3 or 4 of this type of question in a test. Your teachers then may give you nice lenient marks like this for the first question, but in the second question, give you 1 mark for both reductions, 1 mark for your co-ratio, 1 mark for your answer. So it very much depends on the test that you're writing, but in general, so when you go through past papers and stuff, in general, a question like this would be between 3 to 5 marks, again, depending on how much you have to manipulate. All right, but like I say here, manipulations for your 2 reductions, your co-ratio, your answer, if we're feeling generous for the cos 45. Okay, so guys, take your screenshot if you need it. And then let's have a look at example 2, where this is not quite proven identity, but the idea is similar in that you're needing to show that an expression or an equation is true. Okay, so if we have a look at the second example, it is asking us to show that cos of 60 plus theta minus cos of 60 minus theta is equal to -√3 sine theta. So it's not quite a question of prove the identity, but we're going to use a similar logic. Because what it's asking us to do, what it's asking us to do is prove that the left is equal to the right. It's asking us to prove that this equation is true. Please remember, grade 12s, anytime you see a show that question, you cannot then assume that it's true. So we can't work with this as an equation. We need to now apply our knowledge from identities and work with one side, either the left or the right. Now, remember I said this to you before when we did identities. Pick the side that you can actually do something with. So the negative root 3 sine theta, I can't really do anything with that. It's not a compound angle. It's not any of the identities we know thus far. But the left-hand side, we can definitely, English. We can definitely manipulate because they are compound angles. So we're going to work with the left-hand side here, which is this whole cos 60 plus theta minus cos 60 minus theta. And we're going to expand those. Okay, it is going to be quite a gross expansion to start off with, but unfortunately that is just the cos we've been dealt here. So this is cos 60 times, and remember cos is cos, different signs. This will now be minus sine. So cos 60 times cos theta minus sine 60 times sine theta. That is just for, apparently it's not going to work. It's just for the first term. Then we've got the minus, and now we've got our second term going on here, which is the cos 60 minus theta. So this is now cos 60 times cos theta plus sine 60 times sine theta. Okay, so like I said, gross looking expansion. Sorry, I don't know what's happening with that plus sign. We're just going to move on from it. Quite a gross expansion, but we will now be able to simplify what's going on here. Now, again, guys, a couple different ways that you can do this. It's really going to depend on what you see first. So immediately my eye is drawn to the fact that I've got special angles, and I obviously need to deal with this negative and distribute it into that purple bracket. So I'm going to deal with everything at once. Obviously, you can go step by step if you want to. You don't have to. So I'm going to deal with the special angle. Cos 60 is a half, so I've got a half times cos theta minus, and sine 60 is root 3 over 2. So root 3 over 2 times sine theta. Now I'm just going to stop there. This is what I was saying earlier. If you don't know those special angles and you don't remember your triangles, just type it in on your calculator. So type sine 60 on your calculator. You then just substitute the root 3 over 2 into your equation. What's important is that if you use your calculator, you are still showing all of your working out, which is what I'm doing here. Okay, now I need to distribute that negative in. So this will be minus cos 60. Cos 60, as we know, is a half. So negative a half cos theta. And when I distribute that negative in, it's going to change that positive sign to a negative. So negative root 3 over 2 times sine theta. Now, if you didn't see that and you only dealt with the special angles later, fine, no problem. You might have distributed the negative first and then dealt with things. It really doesn't matter, guys. Right, what I then see is that half cos theta minus half cos theta are like terms. And in this case, those like terms actually are the additive inverse, so it becomes 0. And so what I'm left with are the like terms, negative 3 over 2 sine theta minus root 3 over 2 sine theta. So when you subtract both of them, you end up with 2 square root 3 over 2 sine theta. Essentially, you're subtracting the same thing twice. If you had minus x, you would end up with negative 2x. So negative root 3 minus root 3 is equal to negative 2 root 3. You're subtracting 2 of them. So you can almost treat the surd or the root like a variable. It will help you when it comes to like terms, when it comes to adding and subtracting, multiplying, all of those things. Now, if you look at this fraction, the 2 and the 2 can actually divide away. So 2 divided by 2 is 1. And so what you're actually left with here is, or maybe I should keep the negative, is negative root 3 sine theta. Now, if you have a look, that's exactly what we wanted to prove. And so we have proved that the left-hand side is equal to the right-hand side. So essentially, we've shown that it is equal. Right, so guys, remember when it is a show that, prove that, something you're trying to show is actually true, you need to essentially start manipulating what you have. All right, so in question B, whoopsie daisies, it now says, hence evaluate cos 105 degrees minus cos 15 degrees without the use of a calculator. So can anyone tell me what that hence means in maths? Whenever we see that hence, what does it actually mean we need to do? Okay, Chantal, I like what you're thinking. So English. Chantal is saying special angles. So this without the use of a calculator is definitely implying special angles for me. And right now, what I've been given, the 105 and the 15, they aren't special angles. So we have to think about that carefully. So I do agree with you. Special angles are going to come into it. What does the hence mean? Sometimes they'll say hence or otherwise evaluate blah, 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 or prove that blah, blah, blah. No one. Okay, so Chantal's on the right track. The hence means use your answer, or use your previous answer rather. So whatever we just did in this first question A has led us to being able to answer question B. So when it says hence or otherwise, it means either use the question's answer that you've just completed to help you answer this question, or the otherwise part means find a completely new way of doing it. Both are fine, but generally if it says hence or otherwise, use your answer above. It's given you a clue. So what we were given in the question above was the fact that cos of 60 plus theta minus cos of 60 minus theta was equal to that negative root 3 sine theta. So my question to you now is, do you see any relation with what you have been given with what you are now working with? So could you potentially work out what theta is? Could you see some sort of pattern forming here? Is there anything that we can now determine from what we were given to what we're now working with? So if you look at your angles, you've got a 60 plus theta should be the same as 105, and the 60 minus theta should be the same as 15. What does that imply about theta? Remember, theta is the same angle. And go back to what Chantal said, special angle. So is there a special angle that you could add to 60 and subtract from 60 to end up with 105 and 15 degrees? To be so nice. Good, guys. Well done. Okay, so what we've essentially, or what we can essentially see is that theta is equal to 45. If you say 60 plus 45 degrees, you end up with 105. If you say 60 minus 45 degrees, you end up with 15. So what we're actually working with here is a cos 45 situation. Alrighty, so now that we know that, we know essentially what we're working with, because now we can say, okay, cool, based on what I now know theta is, and what I know the expression I've already proven to equal negative root 3 sine theta, I can now say that cos, apparently I can't, we can now say that cos of 60 plus 45 minus cos of 60 minus 45 is equal to that cos 105 minus cos 15 degrees. Now we already know, there's so much going on here. We already know that this statement over here is true. So we already know that the cos of 60 plus theta minus cos of 60 minus theta is equal to negative root 3 sine theta. So we actually already know that this entire expression is equal to negative root 3 sine theta. And you've just worked out what theta is. So technically we know that this whole expression is equal to negative root 3 sine 45 degrees, because you've just worked out that theta by using your values or your previous question's answer. As Chantal implied earlier, special angles. This is now a special angle. Negative root 3, sine of 45 is root 2 over 2. And now, guys, I wouldn't stress about trying to do this in your head. Just type this into your calculator. What actually ends up happening is that, because this is technically over 1, you've got negative root 3 times negative root 2, which gives you negative root 6. You can multiply the numbers underneath the square root, all being divided by 2. So when it says hence or otherwise, use your answer that you've already proven true or that you've already gotten in the first question in order to answer the second question. That's what it's, I can't speak English there. That is essentially what we're asking you to do when we say hence or otherwise. Because we knew from the first question that the cos 60 plus theta minus cos 60 minus theta was equal to negative root 3. We proved that in question A. We could use that fact in question B. That's why in question B, from the point where I substituted in theta, I didn't bother to go and expand that. What's the point of expanding it if I already know that it's equal to negative square root 3 sine theta? I've already proven that in the previous question. So no point in doing all of it again. Use what I know, and then I can go ahead and get my answer. So the hence or otherwise question should not be a rehash of what you've already done. It should not be particularly hard. You're using the answer that you already have in order to get the answer in the next question. Okay, so I'm just going to make this a touch smaller so you can screenshot. And then you're going to try some by yourselves. Again, guys, if you have questions, please just ask as we go along. I know that okay, English is not my favorite language, so clearly. I know that trig is not necessarily everyone's favorite, but it's important to ask as we go along, especially because, like I said, there's often different ways to do things. So you might have thought of a different way to do a question, and the way I'm doing it may not make as much sense for you. So just ask, and I'll walk you through whatever it is that you're confused about. Okay. But here are your two questions that I want you guys to try. You don't have to try both of them. Sorry, my Zoom function today is just wild. You don't have to try both of them. Try whichever one you feel more comfortable with. There's a slightly easier one and there's a slightly harder one. You decide which one you want to do. You don't have to do both. You can do both. It's completely up to you. In the easier question, you want to show that sine theta plus 13 minus sine theta minus 30 is equal to cos theta. And then the second one, you want to show that cos 45 minus theta minus sine 45 minus theta is equal to root 2 sine theta. Right, that's not what I wanted to do. Okay. I was going to copy all your compound angle formula, but I'll just put it down here at the bottom for you, just in case you need it. Like I say, you probably have it somewhere, but just in case you do need it. Right, those are your compound angle formula, just in case you've forgotten. I don't know what this weird shape that I've chosen to draw is, but we're just going to roll with it. Some trapezium looking thing. Okay, so you're giving those two a try. I'm going to give you a few more minutes and then we'll have a look at the answers. If you got questions, just ask as you go along. And again, just give me a thumbs up when you are done with the question you have chosen. Manshika, thank you. Anyone else done? Okay, just give me a thumbs up so I know. Lydia, thank you. Okay, guys, I'm going to give you one more minute and then I'm going to give the answers. If you're not done, don't stress. You can just take a screenshot. Inam, thank you. Morgan, thank you. Right, guys. Okay, so let's have a look at the first one. So the first one, again, pick the side that you know you can manipulate. Because the left-hand side clearly has some compound angles that we can use, that's the one we're going to manipulate. So we go ahead and do that. Now, this one, I'm just showing you a different way that you could look at it. So rather than dealing with the special angles straight from the straight from the outset, what you could go do is you could go and see your like terms. So that's what I've got here. The ones in purple are like terms because they're both sine thetas cos 30, so like terms. The purple ones actually cancel out because it's positive minus additive inverse 0. The pink ones is cos theta sine 30. There's two of them, hence why the coefficient here in the next step is 2. And then you can go and simplify with your special angles. So sine 30 is a special angle, that's a half. You can then simplify it. 2 times a half is 1, which means you actually just left with the cos theta, which is what you wanted to prove the whole time. Excuse me. So again, it's about manipulating what you've been given to what you need. And it's sort of what I said when we were proving identities. Whilst this is not an identity, always just go back to what you're wanting to prove. You're wanting to prove that cos theta. And so through your working out, you should eventually be simplifying to end up with just a cos theta. Right, so that was the first one. If we have a look at the second one, I'll just shimmy on over here. Second one was a little bit more going on, especially because the special angles were not wonderful to work with because it was sine and cos of 45. But the same thing, you've got compound angle formula, expand them, you can then go and simplify. The reason this wasn't a particularly wonderful question is because of the fact that the compound angle formula you were working with didn't match up. So in the previous questions, it was a cos minus a cos, a sine minus a sine. In this case, it's cos minus sine. So the cos compound angle formula is cos cos sine sine, whereas the sine angle formula is sine cos cos sine. So you have to be mindful of that when you were looking for your like terms. Again, I've just showed you that you don't have to do it like that. So what I did is I first dealt with the special angles wherever I could see them. Give me that root 2 over 2 in my terms. Excuse me. And from there, again, I looked at my like terms. So the cos thetas were like terms and the sine thetas were like terms. The cos thetas cancelled out, which is great because what we actually wanted was a sine theta. And when you go and add root 2 over 2 plus root 2 over 2, you end up with just root 2. And that means that left was equal to the right. And so we had proven that this was true. So this question, not as easy as the last question, purely because of the fact that the compound angle formula you were working with was a sine cos rather than the cos cos sine sine. So there was a fair amount of manipulation you had to do, but it doesn't change what you're doing. The method still remains the same. So let's take a screenshot of this, and then we're going to have a look at this next example. Okay, so example 3 is not presented to us as a compound angle. If we have a look at what example 3 is saying to us, it says calculate the value of sine 15 without a calculator. That's not a compound angle. That is just one singular angle by itself. But what we can do is we can make it a compound angle in order to apply our compound angle formulae. Now, again, it says without a calculator. So what Chantal said earlier, without a calculator implies special angles. Okay, so grade 12, my question to you is, what special angles can you add and subtract together in order to get an answer of 15? So for example, 60 minus 30 gives us an angle of 30. What special angles could I add and subtract to end up with 15? Okay, so both Anam and Tabiso have said 60 minus 45. I'm going to be honest, I didn't think of that one until right now, but it'll work just the same. And again, statement I made earlier, just because I think of something else doesn't mean I'm wrong or doesn't mean you're wrong. So Lydia, I thought exactly the same as you. I went 45 minus 30. So let's actually do the 60 minus 45 to prove that it works. And then I'll do the 45 minus 30. But again, both will work because you have applied your knowledge of trig correctly. So I'm going to do both of them just to prove the point, because that's why maths is cool, as much as no one always agrees with me, but that's why maths is cool. Right, so if we go 60 minus 45, we can write this as sine of 60 degrees minus 45 degrees. Both of these are now special angles, which means you can apply your special angle ratios. So 60 minus 2 angles, we're looking at our compound angle formula up there, which you can't see, but I'm going to write it. So it'd be sine 60 times cos 45 minus cos 60 times sine 45. Special angles, use your calculator if you're not 100% sure, or if you know your special angle triangles, you're much better than me, because I think I chucked that out of my brain real quick after school. So sine of 60 is square root 3 over 2. Cos 45, root 2 over 2. Cos of 60 is a half times sine of 45, which is square root 2 over 2. And now you just multiply. So root 3 times root 2 is root 6. 2 times 2 is 4. So root 6 over 4 minus root 2 over 2. Now, guys, what I said earlier, your surds are like terms. So root 6 and root 2 are not the same thing. So you can't just add them to or subtract them together to get a root 4. That's not how it works. Unfortunately, because the number underneath the square root is not the same, you cannot add or subtract them. You could multiply them, but we're adding and subtracting here, so I can't do anything more than just say root 6 minus root 2 over 4. Sorry, that denominator should have been a 4. And that's it. Okay, if you had gone with the 45 minus 30, which like I said is what I actually did initially, you're going to end up with exactly the same thing. You end up with sine 45 times cos 30 minus cos 45 times sine 30. Sine 45 is root 2 over 2. Cos 30 is root 3 over 2. Minus cos 45, root 2 over 2, times sine 30, which is a half. If you have a look, that's exactly what you ended up with there. So this gives us that root 6 over 4 minus root 2 over 4. And so exactly the same answer as we got previously. So guys, remember, just because I've done something differently, just because you've done something differently, does not mean it's wrong. It's the same thing. You've used your special angles, you've applied your special angles correctly, you got the answer. So well done those of you who thought the 60 minus 45, like I said, didn't even cross my mind. My mind immediately went to 45 minus 30. But as I've shown, you get the same answer. So it doesn't matter. All right, guys, well, let's take our screenshot. Unfortunately, don't have time for the you try, but you can see the questionnaire if you want to have a go of it. On Wednesday, we're going to start with our double angle formulae. Start with the basics, then we'll move up to the more complex stuff the following Monday. But if you guys have your screenshots and you have what you need, you're welcome to go. Please don't forget to do the quizzes if you haven't already done them, because I am going to start closing them, like I said, and putting up the full worked out answers for them. I'm going to obviously start with our very first course, which was sequences and series, and then move my way up.